So that's the result from the subjective preference investors investment strategies based on benchmark approach. We next move on to look at a problem of variable annuities with guarantees. So a variable annuity would be a product which at a certain date pays the policyholder a certain guaranteed level of cash flows. And in the meantime, if the market goes well, the investor will receive more payments. So the variable annuity part would be a investment account that tracks some kind of mutual fund index or some kind of investment portfolio. And the guarantee part would be such that if the index fund did not go well, the investor is guaranteed a certain minimum payment, even though the investment portfolio value is less than that amount. So we consider here the guaranteed minimum withdrawal death benefit, which basically says that if the investor has an investment wealth account as well as a guarantee account, where the guarantee account basically allows the investor to make withdrawals regardless to make withdrawals regardless of the wealth account balance. So the model we first consider is a Black-Scholes model, where it's a risk-neutral kind of model. So the model we consider here is a diffusive market model, where we have under the risk-neutral framework, we have a interest rate R, short rate R, volatility sigma, and the BT here, the Brownian motion for the index fund. And the Wells process satisfies tracking this index fund satisfies the similar SDE, except that there is a fee charged to this wealth account, and the fee rate is alpha TOT. So this is a Markovian system where the state variables are the current interest rate, current volatility, current index level, current wealth level, and the current guarantee account balance. And we can augment this information set by an indicator IT, which indicates the liveliness of the policyholder. So IT is 1 if the policyholder is alive, 0 if the policyholder died over the last period, and then -1 if the policyholder dies 2 periods or earlier ago. At every withdrawal date N, the policyholder have the choice to make a withdrawal of amount gamma N, which is of his own choice, which is dependent on the date Tn and the current state YTN. And if the policyholder dies or the contract expires, then the maximum between the wealth account and the guarantee account is withdrawal, which means that if the wealth is more than the guarantee, all the wealth can be withdrawn. If the wealth is less than the guarantee, the amount, then the guaranteed amount will be paid by the insurance company. So the cash flow received by the policyholder is, however, different from the nominal withdrawal. It consists of a payment plus death benefit, where the payment, this is a payment for if the policyholder is alive, and this is a death payment. The payment is given by the withdrawal nominal amount minus any potential charges and the penalty fees. Here, we assume that the fee of a percentage of beta is charged if the withdrawal is made, the amount of withdrawal is made is greater than the scheduled payment, which is typically a constant G, which is uniformly distributed. So if you withdraw less, that's no problem. If you withdraw more, you should pay a little penalty, like 10% or something. And the death benefit is return of the balance on the guarantee account A, or if you have more wealth in your account, return of that wealth to you. So that's the basic detail of the contract. And the guarantee account is such that when you make a withdrawal at time Tn, after the withdrawal, the guarantee account will be reduced by a certain amount. And this amount is either given by the nominal withdrawal or given by the entire balance if the policyholder dies over the last period. So, and the wealth account after withdrawal would be either the current wealth balance minus the nominal withdrawal, or zero if the nominal withdrawal is more than the wealth level. And after the contract expires, both accounts become zero, and the value of this contract becomes zero. So these are some of the boundary conditions of the contract. So we consider first the policyholder's value function, which is a value of the remaining term of the contract as seen by the policyholder, which is given by the withdrawal cash flow that he receives at this period, Tn, plus the value of the remaining part of the policy immediately after withdrawal. And immediately before the withdrawal, we have this value, policyholder's value, to be given by the average of two situations. One is that the policyholder survived. The other is the policyholder died over the last period. And here Qn is mortality. So if there's a Qn% of chance that the value is just the death benefit, there is 1 minus Qn% of chance that the value is given by cash flow received plus the remaining value of the contract. Here Pn should be Cn here. So and over the period from Tn minus 1 to Tn minus, the value process is given by this risk neutral pricing formula. And this value function satisfies this PDE following the standard arguments. So basically, to solve for the policyholder's value function as a function of t is basically recursively calculate the value functions between each withdrawal dates and apply the appropriate boundary conditions. And here's the algorithm that illustrates this process. First, we initialize a terminal value function post withdrawal to be zero, and then we work backwards by applying boundary conditions, solving PDEs, and applying jump conditions, and so forth. And eventually we can obtain the value function at time zero. On the other hand, we can also look at this pricing problem from the insurer's perspective. So the insurance company has a liability to this policyholder, so that if the If the contract has expired, the liability is 0. And the liability at a certain given withdrawal date would be the withdrawal cash flow that must be paid by the insurance company, plus the remaining liabilities. Here is a cash flow that must be paid out of the pocket of the insurance company, which is given by the cash flow entitled to the policyholder minus available fund. So if there's still value in the policyholder's investment account, then the payment to the investor will come out of this account. Otherwise, the difference will be paid by the insurance company. Similarly, before any withdrawal at a certain withdrawal date, the insurance company does not know whether or not the policyholder has died. So the average value of an individual liability would be given by the mixture between life and the death of the policyholder. And the liability value between two withdrawal dates is again given by the risk-neutral pricing formula. Here, the first term represents the liability value. The second term is the value of the insurance fees that will be received by the policyholder, by the insurance company. So the net liability will be the difference between the two. And the fair condition is such that the initial liability is 0. And to compute the liability, we follow a similar backward induction procedure. Next, we are looking at another value function, which is wealth manager's value function, which is the difference between the sum of the net liability plus the wealth minus the value function of the policyholder. So this is what the insurance company owes. This is what is the available wealth, and this is what the policyholder is entitled. The difference is some value that it will be received by the manager of the portfolio. So this is 0 at 0 because all three terms are 0. And there's no withdrawal. There's no, and this wealth function is right continuous at a withdrawal date. And before the withdrawal date, the wealth function is defined to be right continuous at a withdrawal date. And before the withdrawal date, if the policy terminates due to the death of the policyholder, then there will be no more value for the wealth manager. Otherwise, it will continue to receive the post-withdrawal manager's value function. So the probability of continue would be 1 minus the mortality rate. So that the initial wealth, the initial policyholder's value is equal to the initial value in the investment account minus this management value. So by investing in this insurance contract under fair conditions, the value of the policyholder is given by the wealth available minus the expected management fees that is going to be paid to the wealth manager. So this is under the risk neutral pricing theory, and this is obviously reasonable. So from a policyholder and from an insurance company's point of view, there are different ways to make withdrawals. For the policyholder, at any date, Tn, if he's still alive, he will decide on what kind of nominal withdrawal to make. And this withdrawal is supposed to be to maximize the value, which is the current payment received plus plus the remaining value in the contract. Whereas for the insurance company, he would expect that the policyholder to maximize the payment that must be paid by the insurance company plus the remaining liability. So the first is maximum policyholder's value. The second is maximize the insurance company's total liability. If there's no market friction, then these two values are the same. These two withdrawal strategies will also be the same. But if there's a management fee charged by the fund manager, as we can see, the values are different. LT and VT differs by the wealth manager's value function. So having different goals will lead to different withdrawal behaviors, which will also lead to different valuation of the contract. So here we have some example that show this difference. So we consider market situation where the risk-free rate is 1%, volatility is 30%, and the penalty on over withdrawal is 10% or 20%, and the maturity is 5 years, 10 years, or 20 years. So there are 4 different situations. Actually, the withdrawal, the maturity is 10 and 20 years. 4 situations, 2 by 2. So we have calculated the fair insurance fees that need to be charged by the insurance company to break even as a function of the rate of the management fees. So we have 2 different fair fee rates. One corresponds to the strategy of maximum value. The other corresponds to the strategy of maximum liability. So the maximum value fee is actually lower than the maximum liability fee by definition. And this discrepancy can be seen most obviously under this third situation where penalty is 10% and maturity is 20 years. And on the other hand, the policy value as seen by the policyholder following these 2 different strategies also differs. If the policyholder follows a value maximization strategy, it gets more value as depicted by this curve. Otherwise, if they actually follow the liability maximization value, which can be thought of as maximizing the guarantee value, then the actual policy value he receives is less than what he could have received. So, and this is also partly due to the fees that have been overcharged by by the insurance company. So this is one scenario. The other scenario is more pronounced, where we consider a risk-free rate of 5%, volatility of 10%, and 10 years and 20 years of time horizon, and 10-20% of penalty of over withdrawal. So it can be seen clearly in this particular situation, the fair fee as a function of management fees actually increases first and then decreases at a later stage, which means that the more management fee that is charged by the fund manager, the fair insurance fee actually decreases. This is due to the fact that if the management fee is high, the policyholder have a motivation to early withdraw despite the penalty. So since early withdrawal will generate revenue for the insurance company by charging penalty fees, to be fair, the insurance company should charge less insurance fees. So 3 of the 4 scenarios reveal such a pattern where the fair fee actually decreases with increase in management fees, which cannot be the case if the policyholder attempts to withdraw such that the liability is maximized. So in summary, there are these situations where the fair fees implied by the two strategies differ more significantly. That is long maturity, low penalty rate, high interest rate, and high management fees. Both situations imply that the fund manager will receive more management fees, making the two value function differ by more, so that the strategy differ by more. So this is a study under risk neutral pricing theory.